Happy Late Start Wednesday. Math notebooks. Oh, you're okay. All right, yesterday we talked about data and all the different ways that we can represent and show data. Today, specifically, I want to dive in deeper to line plots. So, without further ado, lights please. And let's start off the day with a jam.
Yeah. Sunday best.
Usually they're like super upbeat. This one's kind of more mellow, chill. All right, I actually got a couple things to show you guys. I found a video clip and another song that I liked a lot too that I wanted to show you guys. Yes, Khan Academy, coming back to it. I told you guys, it's got some good stuff for math.
Let's say we're having a birthday party, and these are the kids at the birthday party. And all of the kids, they have a bunch of different ages. And what we are curious about is, how many kids of each age do we have? Well, to help think about that, we can draw what is called a line plot. And I've always viewed the term line plot a bit confusing, because in my brain you use a lot more dots than you use lines. But let's look at what a line plot is. So what I will do is, I will draw, I guess this involves a line right over here. I'll draw a line down here, and then I'll create buckets for each of the ages. So let's see, I have students here from age 3 all the way to age 7. So I could say age 3, age 4, age 5, age 6, and age 7. I don't have to go to 2, or I don't have to go to 8. There aren't any kids in those in those ages, although I could if I want. And then I look at, well, how many kids do I have of each age? Well, I have one person attending the party, Dia. She's age 3. So I might put an X here, or I could put a dot here. Different line plots would put different things here. But that shows me that I have this partier is age 3 right over here. Now I have Imran, age 5. So that's someone right over here who would be age 5. You could think of this dot. This represents Imran, who's age 5. Then you have Surya, who's also age 5. So he's also age 5, so that means we have a second person at the party who is age 5. So under age 5, we now have
Now I want to point out in his video that he's using dots to represent these data numbers, correct?
Yeah.
I think more often than dots, I think you're going to see X's, okay? Either would be correct, not great big X's that take up the whole paper, just the equivalent size of that dot, you would see a small X, okay? So just FYI, that doesn't mean anything differently. It's just a different way to kind of make those tallies, those data numbers.
people. This is Imran, and this is Surya. Then you have Jasper, who is 6. So that's one person who is age 6. Then you also have Vikram, who is age 6. Oops, let me do that in that same color. We also have Vikram, who is age 6. So let's put him in the age 6 bucket. Then we have Luke, who is 7. Luke, who is 7. So that would be a dot right over there. And then finally I have Anya, who's also age 6. Who is also age 6. So just like that, I was able to take all of the data that I have in this table, and I'm able to put it on this line plot. And the reason why this line plot is useful is it helps us look at, well, how many of each age do we have? It might be a little bit more confusing to just look at the table here. Because when you look at the line plot, it's very clear. Hey, look, there's no one here who is age 4. And look, we have the most people who are age 6. And if we asked ourselves a question, well, how many, if you didn't even have this, actually, let me just even take it away. If we didn't even have that there, if we didn't have the table, and we just had the line plot, and if someone said, hey, look, these are ages, right over here. This is our ages in years old. And each dot represents a student who's at the party. So based on this line plot, how many people are more than 5 years old?
Well, how many people are more than 5 years old? 4. Don't get confusing. We don't count the ones who are 5. It was more than 5 years old.
Well, you could look at this and you could say, okay, more than 5 years old. That would be 6 years old or 7 years old. It's not showing anyone who's 8, 9, 10, 11, and on and on and on and on. So let's look at all the dots. Let's look at all the dots here that are more than 5 years old. There are 3 6-year-olds and there's 1 7-year-old. So there are 1, 2, 3, 4 people who are older than 5 years old. You can go the other way around. You can say how many people are less than 5 years old. Well, then you could say, okay, less than 5 years old would be either 3 years old or 4 years old. And when you look at those dots, you see there's only one dot. Only one person attending the party is less than 5 years old. Hopefully you found that interesting.
All right, and I have one more song for us because when you guys do line plots, because you are in 5th grade and not 3rd grade or 4th grade anymore, and almost middle schoolers actually, when you guys do line plots, most of the time you're going to see line plots with fractions, okay? They will be using fraction numbers. Our comprehension, understanding of a line plot does not change. You guys know how to do fractions, okay? That's just the numbers we're using. Gives it a little bit more challenging in there. Good question. So say for your line plot, your data numbers were 3, 4, and 6. Yes, still write 5 because you have to make sure your x-axis, that's that bottom line, that it's spaced numerical order, okay? You couldn't have a big gap in there for 6 or put 5 and 7 right next to each other, okay? They need to be spaced evenly and equivalent.
Yeah. We're in the 4th grade analyzing the data we got.
You're in 5th
about
grade.
how many inches we grew in a year on the line plot. First we'll find a common denominator. Next we'll convert to equivalent fractions for the data. From 0 to 4 inches, we'll draw the line plot. Our intervals to quarter inches, each is given a spot. We'll plot each data point, and we won't stop until the unit's on the bottom and the title's on the top. Top.
Let's find a common denominator, make equivalent fractions for all the data. Plot what you got on the line plot with the label and the title at the top.
Now we're writing the 5th graders' growth data down. How many inches they grew in a year is what we had found. First we'll find the common denominator. Next we'll convert to equivalent fractions for the data. From 0 to 4 inches, we'll draw the line plot. Our intervals to quarter inches, each is given a spot. We'll plot each data point, and we won't stop until the unit's on the bottom and the title's on the top.
Let's find a common denominator, make equivalent fractions for all the data. Plot what you got on the line plot with the label and the title at the top.
Now we'll analyze the 2 line plots we made and see that students grew more in the 4th grade. The 5th graders grew less, but that was okay, cause overall the 5th graders are taller anyway. And we 4th graders don't care, we may be shorter, but we rock math every week of every quarter.
Let's find a common denominator, make equivalent fractions for all the data. Plot what you got on the line plot with the label and the title at the top.
Alright. That's all of our jamming for today, guys. I am going to leave this light off, though. I want to show you guys. We're going to do some line plot practice now. And our line plot practice is going to be on math courses for Schoology. And I want you to save this line plot anchor chart. So again, if you're having some questions on your homework, you're kind of like, oh, I can't remember everything about line plots. This is a nice chart here that is going to show you, it tells us that line plots show how frequently something occurs by displaying data on a number line. We have here, see this one, they use X's on this one instead of those dots. Each X represents 1 vote. Each fraction shows the amount of sugar used. We label down here. This one doesn't have a title. They have their label on the bottom, but it should have a title too. Okay? All right, let's practice. Let's do my right light on and let's see how that looks. All right, I think we can work like that. All right, we have here, actually, let me see, I'll zoom in for you guys. Dun, 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 dun. Oh, too much. Whoa. All right, let's practice. All right, so we're going to be making our own line plot here. Okay? So it says, right there. It says that Mrs. Robinson recorded how long each of her students spent reading during a single school day. She recorded the results, which are in hours, below. So here are all the results. So somebody read for a half hour, somebody read for 1.5 hours, somebody read for 1, and so on. Okay? We have to organize these results from least to greatest in order to get ourselves ready to make this line plot. Okay? So from least to greatest, let's organize our numbers. So I'm going to leave that there for a second. And your math notebook, ladies and gentlemen, you are doing this. So we start with 0. How many zeros? So students who read for 0 hours. I see 1, 2.
2.
1, 2. Separate your numbers with commas, just like they did. All right, how many read for a half hour? 1, 2, 3, 3. So 1/2, 1/2, 1/2. 3 times. I'm going to scroll you guys over here. You can write along with me then. All right, how many read for 1 hour? I see 1, and that's it. How many read for 1.5 hours? 1, 2, 3, 4. 1, 2, 3, 4. Ladies and gentlemen, nobody is sitting. Everybody is working in their math notebook, putting our data in order from least to greatest. All right, how many read for 2? 1, 2, 3. 1, 2, 3. Did any read for 2.5? I don't see any for 2.5. About 3. 1, 2. And then that's where it stops, right? Yes. I'm going to go right below because I ran out of room and put 2 3s. All right. So we have organized it now from least to greatest. Now we need to see our line plot line. Now, ladies and gentlemen, you guys have lined paper. Make your line on one of the blue lines that you guys already have, and that helps make it nice and straight. All right, I'm just going to do my best for a straight line. There is my straight line. All right, we need a title for our line plot. What were this data numbers about? Reading. So I would say specifically Mrs. Robinson's reading class or reading log. This is kind of like their daily log. All right. My x-axis down here, what were these numbers in? 0 minutes, 0 hours, days? Hours. So we want to label it hours. Very nice. Hours. All right, now we need to put our numbers. Well, that's where putting it from least to greatest helps us now. What was my smallest number on my timeline here? 0. And my largest being? 3. Now I want to point something out to you here. For example, let's say my data numbers start at 60 and went to 80. You guys all have to think about what numbers you're going to put on your timeline. If my numbers don't start at 60, do I want to start at 0? No. I'm not going to be able to make my timeline big enough, right? Yeah. I would start your timeline then at 60. Okay? You also have to think about what size increments. And this is kind of like Malia's question. She's like, so we don't have a 2.5. Do I need to put 2.5 on here? Yes, we need to have equivalent increments. Our increments, they kind of justified and made for us. They are moving by how much? Halves. Yeah, so I'm going to start with 0 and increase by a half. Okay? What if we were going from 60 to 80? What kind of increments? Do you think ones? No, ones is going to be probably a lot, right? I would do tens. Tens, I think is actually maybe going to be too small because that's only going to give you 60, 70, 80. That's only going to give you 3 increments. I would say maybe 5s. Yeah. So you could do 60, 65, 70, 75, 80, possibly even 2s. Okay? You have to determine that increment for your line plot. Okay? Something that's not going to be too big. Like we said, tens for this would be too big. It would only give you 3 marks on your line plot. Okay? We want to try and have some more than that. All right, so let's go ahead and do this. So I'm going to start here at 0. Ladies and gentlemen, I am not going to ask that you measure these out. We're going to do our best to space these out evenly. 0, 1/2, 1, 1.5, 2, 2.5, and 3. If you wanted to put, I have a little space here. If you want to put 3.5, you can. Not needed. but they look pretty evenly spaced. Again, we're not using a ruler, just gonna do our best. All right, now it's time to go ahead and plot our numbers. I like using X's, but like you saw in the Khan Academy video, you could use little dots, that's fine too. So how many zeros do I have? And I'm gonna cross them off as I go to make sure I use them all.
2.
2, so 1, 2. How many halves? 1, 2, 3. 1, 2, 3. Same thing with your X's. You want to try and make all of your X's about the same size. How many ones?
3.
I see 1. How many 1 and a half? 4. 1, 2, 3, 4. How many 2s?
3.
1, 2, 3. How many 2 and a halves?
None.
None. So I leave it blank. I don't do anything. How many 3s?
2.
2. How many 3 and a half?
None.
None. We are done. Now, ladies and gentlemen, when you guys see line plots then, typically they're going to ask you some questions. All right, this should be in your math notebook, guys. So my question to you, what was the time spent most for reading that night?
3 hours.
3 hours? Ooh, good question. I like the way actually that went. So I said what was like, you took it as like what was the highest number, which was 3. I should have worded it more correctly. I was meaning, yes, which time spent for reading was most frequently, yeah, did you see on the chart? Justice? 1.5, yes. I'll make sure I'm more careful about wording. What was the least amount of time spent reading? Least amount of time? 0. Good. What was the time frame that nobody read?
2.5.
2.5 or 3.5? Yeah, nobody read for that amount of time. Range. They might ask you range. Do you remember what range was? Malia?
It's the biggest number?
Yes, the biggest number minus your smallest. So my biggest is 3 minus my smallest is 0. So 3 minus 0 is 3. So my range is 3 there.
Yay, easy math.
All right. What do you guys think about line plots?
I like them.
You like them? They're not too hard?
I like the writing.
All right. Ladies and gentlemen, your math homework is a vocabulary on line plots. All right? Sound good? Any questions?
Nope.
All right.